All right, matrices now. So we've got to say in total how many sandwiches were sold in the 3 weeks. We're just adding up those three numbers. Not too hard. Well, too hard for 11% of people, but most of us would have got that quite easily as 159. You don't have to write sandwiches as a unit. There you go. That was just extra for you. And then it says M12. So remember, it's the element in row I and column J of the matrix is given by Mij. It's a basic statement of what happens in the thing. Remember, it's rows, then columns. Roman Catholics or remote control cars or whatever it is that you remember. So it is, let's just get rid of that. It is the first row and it is the second column. So what's the number we get there? There's only one number there. It is 24. So what does the element M12 indicate? It says what's how many rolls, because it's in the R column in week 1. So it's how many rolls were sold in week 1, which was 24. How the number of rolls sold in week 1, which was 24. All right. It says here some students just simply gave the element 24. That would be wrong because it says what does the element indicate, not what is the number. So the key word to highlight there was what does the element indicate. So that's probably where people got that wrong, just being a bit, rushing it a bit, I guess. Okay, so let's consider the matrix equation that we have in front of us, and it's trying to get us to figure out what is the cost of one sandwich. This looks like a classic case of we've got A, we got X, we got B, so we need to stick into a calculator the A and the B, and then do A hat neg 1 B on your calculator, like that. You don't have to do A or B, by the way. You could just use the X and the Y buttons on the very front of your calculator. And then you get this out the bottom here. And we need to find sandwich. Which one was sandwich? C was sandwich. So we want this value. Don't forget, it says what's the cost. So it's $3.80. Put the 3.80 and the dollar sign to get your full marks. All right, so far so good. Let's look at the CII, and it's saying we want to have a matrix equation below that shows the total of rolls and sandwiches. Okay, so this is basically means if we want to find the total, we want a summing matrix. But we don't want to sum the whole damn thing, all right? We just want to sum rolls and sandwiches. So if we remember, it's A, B, C. So that's pies, and that's rolls, and that's sandwiches. So we don't want to multiply. We want to get rid of that. So we've got to multiply that by 0 and the other two by 1. Now it says matrix L is of the order 1 by 3. So it's row by column. Apparently column equals to be able to do column by row. It tells you follow the instructions. So we want a 0, 1, 1. And don't forget your square brackets for your matrices. And that's the answer, because if you work that out, if you actually do multiply those, and you can always double check these things, put it into your calculator and multiply it through, it will give you the right answer. So if you do 0, 1, 1 times the other equation, you'll find that works out. Because remember, it's row by column. So this guy, sorry, using the wrong part of the pen. This guy is multiplying this one, and this guy multiplies this one, and this guy multiplies this one. And you can see that that's why the pi's gets eliminated and the other two get summed up, because you've got, and let's just remind ourselves about multiplying, if you've got a 1 by 3 times, which we do as a dot with matrices, a 3 by 1, we know yes we can, and the size of the answer, making a smiley face, is a 1 by 1, and that is in fact a 1 by 1. Notice you really, this happened before, you've got to put those square brackets on matrices or you just lose the mark. It's 1 mark. If it's not there, it's not there. Fairly easy question to start with. It says if we got P and we're going to S, what is the percentage from that? So P to S is this one, so it's this number. So 40%. Don't forget your percentage symbol, and 95% of people got that right. Easy peasy lemon squeezy. Let's look at the next one. Now, I've included the diagram again in the bottom corner here because it's referring to that. You see, we've got this 300 here, which is this 300, and then we've got this 240, which is this 240, and then we've got this 210, which is this 210. All right, so it says 306 junior students are expected to choose sports in term 2. Complete the following calculation to show this. So we just want to know all the people going into sports. So the P's going to S, remember, that was what the last question was saying, was 40%. So we've got to write that as a number, and it's just in red, 0.4, because that's what 40% is, 40%. Per means divide, cent means 100. How many times have I said that? Now, the other one, green, is sandwiches, still staying as sandwiches. So that's the guys going around like that, and that's the 60%. So we write 0.6 for the same reason we wrote 0.4 before. And then the last one is the, what was it? Did I say sandwiches? It's whatever S is. And then the T coming up into here, which is 20%, and we write that as 0.2. And again, these are the kind of questions that they kind of give me questions, because you could just type 300 times 0.4 plus 240 times 0.6 plus 210 times 0.2 and see, does it equal 306? Does it equal this? And if it doesn't, then you've made a mistake and try again. I mean, I'm really annoyed by these questions at how ridiculously easy they are. Common mistake, of course, was to not put these as decimals and to leave them as percentages. Didn't get the mark for that, because 300 times 40 plus 240 times 60 plus 210 times 20 does not equal 306. Would actually equal, 30,600. All right, in term 4, how many junior students in total are expected to participate? This was a trick question. You could have spent ages on this and realized, well, if you're talking about all 3 sports, the total doesn't change. There's no one coming in or out. There's no pluses or minuses to our metric system, so it's 750. You could have actually sat down and worked out term 4, and apparently people did, and then they had rounding areas and wrote 749. What did you do with that one student? Why did you lose him? It's very careless if you're a teacher and you lose a student. Okay, how many students? We've got all this transition matrix, and we've got some our starting position S1 at the bottom there, and a recurrence relationship for how to do this. But the question is, how many senior students will not change their elective? So the interesting thing about this is knowing that on the diagonal, that's the not changes. So C goes to C, I goes to I, P goes to P, and S goes to S. So you're actually only looking at those numbers. And if we look down the bottom here, this is your C, I, P, S, and that's your S1. So from term 1 to term 2, it is simply 0.4 times 300. Then you've got to add the, those two numbers. Then we've got to do the 0.4 times 200 plus 0.3 times the other 200 and then plus this 0.2 times 300 plus 0.2 times 300. If you stick all that together into your calculator, you get 320, so you can write 320. Just as you can put the number, you don't have to write 320 students. You can if you like. Amuse yourself. All right, complete S2, the state matrix for term 2 below. Well, looks like time for the calculator. So here's I've put in my transition matrix, T. Again, you have to write T if you don't want to, if you don't want to spend ages looking on the keyboard. There's my S, and so to get S2, so let's remind ourselves from the thing, Sn plus 1 equals Tsn, so therefore S2 equals Ts1. Hit all the calculator for that. I get that, which is this guy here. So all I got to do is take those numbers. You can see what I've written on the calculator there, hopefully. And so you just got to fill in the values, which are 250, 250, probably in less shaky handwriting, 300, and 200. All done. Okay, major problems with this question for people, particularly trickily worded, I think, personally. Let's have a look at this. So we've got to think of the senior students expected to choose, so we've got I in term 3, and what percentage of those chose services in term 2? Well, I hit my calculator on this. So let's do some writing on the screen. So that's S1 equals that, that's S2 equals that, and that's S3, which is going to help us because we need the term 3 and the term 2, yes? Now we've got to remember our writing as CIPS, CIPS. So from our other previous diagram, we know we want to go from, in term 2, we had a certain number of service students. So we had, let me highlight that number there. So we're doing this last part, which is in term 2, 200 we're doing services, right? And then from the other diagram, which you saw before, I haven't put a copy up yet, of that, services, services going to I is 0.3 from that diagram, which means it's 30% sort of thing. So we know we've got to say we had 200 times 0.3 became the I, which is, that's 60, yes? So if we look at this number in term 3 for the I, there was 240 students, but we know 60 of them came from the services in the previous term, and that's why it is 60 over 240, which is a quarter, which equals 0.25, which equals 25%. The real trick was getting this from the diagram here and looking at the change in numbers. So what of the 200 let's just highlight it as we go through the process. In term 2, we had 200 people doing services, but we know 0.3% of them, 0.3 of them went to there. So 0.3 of them are there. And so we know that the total was 240, but 0.3 of the 200 was 60. So 60 of them are in there in the term 3. Yeah, very badly done. Only 12% got the full 2 marks. Okay, this one was only half the students got this right, but we're looking for the maximum number of students. So some people mistakenly assumed this was talking about steady state, but it's asking about the maximum number any time during 2018. So I guess at the end could be T4 or something. All right, but we're told remember at the very beginning, we had S1 for gave us that I equals 200, and we did some stuff on the calculator, and we found that I, which is the second one, was 250, then 240, and if you did steady state, you did to power 50 as I've done here, you can see it sort of settles down to 239, and so a lot of people put 239 because they thought it was a steady state question. We said the maximum, well, we got 200, 250, 240, 239. You can't have a fraction of students, remember. Well, the maximum number I can see there is 250. A little bit tricky there, but that's where people went wrong. They assumed there must be a steady state question, and it was asking for a maximum.